Hi guys, welcome to part 2 of our chapter 11 overview. In this part, we're going to start off by talking about congruent parts of circles. So you may recall that we talked about this angle here, this central angle. Now, if I have two congruent central angles, either in the same circle, then I know that these arcs are congruent as well, because remember, the arc length is equal to the central angle length. Okay, now if I know that circles are congruent and I know that the central angles are congruent, then I know that the arcs that they make are congruent. But you have to make sure the circles are congruent. Now, if I know the two arcs are congruent, I can then say that the central angles are congruent. Okay, and the last type of congruence that we generally look at in these circles is if I have congruent chords. Okay, if these chords are congruent, then I know arc AB is congruent to arc BC. And actually the reverse also works. If I know the two arcs are congruent, then I know the two chords are congruent. So let's take a look at some examples where we apply this congruence to make some equations. In example 4, they tell you that chord RS is congruent to chord TU. So we need to find the measure of arc RS. See if you can do that and then press play to check your answer. I knew that if these two chords were congruent, that these two arcs must be equal. So all I did was I said 3x equals 2x plus 27. I made an equation. Then I subtracted 2x on both sides to get x equals 27. Now finally, I took that 27 and put it in for x up here, and I did 3 times 27. So arc RS happens to be 81 degrees. Let's take a look at another example. In part B of this example, they tell you that circle B is congruent to circle E. Okay, so I know that these two circles are congruent. And I also know that arc AC is congruent to arc DF. So those are congruent arcs. And they want me to find the measure of angle DEF. So see if you can do that and then press play to see if your answer is correct. So because the circles are congruent and those arcs are congruent, I know that these two angles are equal. So I did 5y plus 5 equals 7y minus 43. Then, to solve this, I subtracted 5y from the 7y, and I added 43 on both sides. So I got 48 equals 2y. Then, I divided by 2 on both sides to find out that y is 24. All I need to do now is take this 24 and put it in for the measurement for DEF. So I did 7 times 24 minus 43. And I got 125. So angle DEF is 125 degrees. It's time for another check it out question. In check it out number 4, part A, they've given you two congruent circles, and they told you that CD is congruent to EF. So you need to find the measurement of angle EBF. So this angle right here. In part B, they told you the circles are congruent again, and they told you that chord CD is congruent to chord EF, and they want you to find the measure of arc CD. That's right here. So pause the video and see if you can do that, and then press play to see the last thing that we're going to talk about. The last thing we need to talk about is inscribed angles. An inscribed angle is an angle inside a circle, but notice the inscribed angle has a vertex on the circle. It's not at the center anymore. Okay, so that's the difference between a central angle, which just starts at the center, and an inscribed angle that has a vertex over here. Okay, the intercepted arc is the arc that it creates on the circle. And there's a theorem about the inscribed angles. It says that the measure of the inscribed angle is half the measure of the arc. So if I know the arc measure is 100, then I would know the inscribed angle is 50. If I know the inscribed angle is 50, I double it to get the arc length, okay? So let's take a look at some examples with this. In example 5, they ask us to find each measure, and in part A, they want the measure of angle RST. So what I like to do with something like this, where there's a lot going on in the picture, is I like to highlight the angle that I'm interested in. I'm interested in this angle, okay? So the intercepted arc is down here. It's 120 degrees, which is labeled right here. So see if you can figure out this angle measure and then press play to see if you're right. So I remember that the inscribed angle theorem says that this arc, if I cut its measure in half, I will get the inscribed angle. So I just have to divide 120 by 2 to get this angle measure of 60 degrees. In part B, they want the measure of arc SU, which is up here, SU. So I look to see which angle actually creates arc SU. So I trace this line back, and here's the vertex, and I trace it up to S. So it's this 40-degree angle. So see if you can figure out the measure of arc SU, and then press play to check your answer. Now I remember that this arc is twice as big as this angle. So I did 40 degrees times 2 to get 80 degrees. SU is 80 degrees. It's time for another check it out question. In check it out number 5, they want you to find each measurement. In part A, they want the measure of arc ADC. And ADC is almost all the way around the big circle. So see if you can find that one. In part B, they want the measure of angle DAE, okay, which is this angle right here. So pause the video, see if you can do that, and then press play to see the last example we need to do. In example 6A, they want us to find the value of x in this picture. Notice we have this angle here. It is an inscribed angle, and they've given us a hint about it by giving us the diameter here. So think about how big this arc length needs to be and what that would mean about this measurement across from it. Then try and write an equation and solve it to find the value of x. Then press play to see if you're right. So what I remembered is that a full circle is 360 degrees, which means that half the circle is 180 degrees. So this arc is 180 degrees. I can also figure it out by realizing that this is a straight angle, which is 180 degrees. Okay, so this arc is 180, which means that this angle is half of that. Half of 180 is 90. So that means that 4x plus 6 equals 90 degrees. Okay, so all I did is I wrote my equation, I subtracted 6 to get 4x equals 84, then I divided by 4 to get x is 24. Sorry, x is 21. So let's take a look at one more example of this. In part B, they want us to find the measure of angle ADC, which is here. Now, it's a little hard to figure this one out, but see if you can do that. They've drawn a few different inscribed angles. See if you can figure out how they all relate to each other, and then try and write an equation and see if you're right. So what I realized is this angle here, CDA, intercepts arc AC. And angle CBA intercepts that same exact arc, which means that these two angle measures that they've given me have to be equal because they intercept the same exact arc, which means they intercept congruent arcs because it's the same one. Okay, so these two measures have to be equal. So I just made an equation stating that they're equal. I subtracted 7y on both sides and I added 28. So I got 3y equals 27. Then I divided by 3 on both sides to get y equals 9. So I found that the measure of ADC is 7 times 9 minus 1, which is 62 degrees. So there's one last check it out question coming up next. In check it out number 6, they want you to find the value for each of these. So in part A, they want you to find the value of z, which is in this expression right here. So see if you can figure out how to create an equation and solve for z. In part B, they want you to find the measure of angle EDF, which is this angle right here. Okay, EDF, that one. So see if you can do that, put your answers on your response page, and don't forget to submit it. And please let me know if you have any questions about anything.